From design to reality, how a $1 billion offshore platform is built. Offshore oil and gas platforms represent the pinnacle of engineering and industrial design, often involving multi-billion-dollar investments, cutting-edge technology, and the coordination of thousands of workers over years of planning and construction. When we consider an offshore platform costing around $1 billion, the complexity and scale of the project are staggering. These massive structures, which serve as production hubs for energy exploration and extraction, not only symbolize technological achievement but also reflect the economic and environmental challenges of modern energy production. Before we get started, subscribe to our channel and turn on the notification bell so you never miss our latest content. The early stages, concept and design. The journey of building a $1 billion offshore platform begins long before any materials are ordered or welding torches are lit. The first step in the process is conceptualizing and designing the platform. This phase typically lasts for several years and involves extensive research and analysis. Feasibility study and site selection. Before any design work can begin, a feasibility study is conducted to determine the viability of the project. This includes evaluating the geology and geophysics of the offshore location, estimating the size of the oil or gas reserve, and considering environmental factors like ocean currents, weather conditions, and proximity to shipping lanes or protected marine areas. A detailed site survey, including the deployment of seismic and other geophysical testing tools, helps engineers determine the best platform type and design. The depth of the water is also a critical consideration in choosing the platform's construction and stability requirements. Platform design. Structural design. The platform must be designed to withstand the harsh offshore environment. This includes ensuring stability in extreme weather conditions like hurricanes and strong ocean currents. The structure is also designed to bear the weight of drilling equipment, living quarters for the crew, and other necessary equipment. Material selection. The choice of materials is critical for the platform's longevity. Steel is commonly used for the construction of the base and support structure, while specialized coatings and corrosion-resistant materials are chosen for underwater components. These materials ensure the platform can last in the corrosive marine environment. Drilling and extraction equipment. The platform must accommodate complex machinery for drilling into the seafloor and extracting oil and gas. Special care must be taken to design platforms that minimize the risk of spills, leaks, and other hazards. Compliance with international safety standards and regulations is a priority. Safety and regulatory compliance. The offshore oil and gas industry is subject to stringent regulations from national and international bodies, including environmental regulations, safety protocols, and worker welfare standards. In many cases, platforms need to be certified by multiple regulatory agencies before construction begins. To ensure compliance, the design must address factors such as emergency evacuation systems, fire suppression systems, and the provision of medical facilities. Moreover, the design must include systems for monitoring the environmental impact of the operations. Construction in shipyards. The construction of the platform typically occurs in large, specialized shipyards. Depending on the design, these shipyards may be located near the coast or at inland locations, where the components are built and then shipped to the assembly site. At the shipyard, workers fabricate the substructure, assemble the topside modules, and prepare the components for transport. These projects can take several years to complete and involve an extensive labor force. The transportation of large and heavy components requires specialized vessels known as heavy lift ships. These vessels are capable of carrying thousands of tons of equipment, and their cranes are used to lift and position large components onto the platform structure. Transport and installation. After the components are built and assembled, they must be transported to the offshore site. The transport process can be challenging, especially when components are large or the construction site is located far from shore. Specialized vessels are used to transport the materials to the platform location. Once on site, the platform is assembled, and the individual components are carefully lifted and positioned by large cranes. For fixed platforms, the jacket, or substructure, is placed on the seabed using dynamic positioning systems or tugboats. For floating platforms, towing and anchoring are performed with the help of tugboats. In some cases, entire platforms are floated into position and then ballasted to sink to the desired depth, where they are secured with anchors or other mooring systems. Commissioning. After the physical construction is completed, the platform must undergo commissioning. This involves a series of tests and inspections to ensure all systems are functioning correctly. The drilling and extraction systems are tested to confirm that they can safely and efficiently operate. Electrical, communication, and safety systems are all checked to guarantee their reliability. Environmental monitoring systems are also put in place to track emissions, spills, and other potentially harmful environmental factors. These systems ensure compliance with regulatory standards and help mitigate environmental risks. Operational and maintenance phase, routine maintenance. Even the most advanced offshore platforms require regular inspections, maintenance, and repairs to ensure they operate safely and efficiently. This can include everything from replacing damaged parts to ensuring the integrity of the platform's structural components. Given the offshore location, maintenance crews often live on the platform for weeks at a time. These teams are responsible for ensuring the smooth operation of all mechanical and safety systems. Upgrades and modifications. Technology is constantly evolving, and offshore platforms may require upgrades to maintain efficiency and comply with new regulations. These upgrades can include everything from the installation of more advanced drilling equipment to improving the platform's environmental performance. The costs and economic impact. Building a $1 billion offshore platform is a significant investment, and the costs involved in its construction are often spread over several years. The overall cost depends on the platform type, the location, and the specific operational needs. While the initial construction costs are steep, the long-term returns can be substantial. Once a platform is operational, it has the potential to generate billions of dollars in revenue through the production and sale of oil and gas. However, the costs are not without risks. Offshore platforms are vulnerable to environmental disasters, such as oil spills, and are subject to market fluctuations in the price of oil and gas. If you enjoyed this video, give it a thumbs up and subscribe for more content. Hit the notification bell to stay updated with our latest videos. Share your thoughts in the comments below. Thank you for watching.